Hello, welcome to today's lesson on understanding internal energy. Today we'll explore internal energy and understand that internal energy refers to the total energy stored within a substance due to the motion and arrangement of its particles. Then, with the help of an analogy, we'll make sense of potential energy and understand that in materials where particles are farther apart, such as gases, the potential energy is higher. Finally, we'll look at how kinetic energy refers to the movement of particles and the effect temperature has on this. So far, you are familiar with the particle model of solids, liquids, and gases. We have seen how particles are arranged and how they move differently in each state of matter. Building on this foundation, we can now introduce the concept of internal energy, which will deepen our understanding of how energy is stored in different substances. Let's get started. Internal energy is a term used to describe the total energy stored within a substance due to the motion and arrangement of its particles. This energy is a sum of two types, kinetic energy and potential energy. We'll expand on these one by one. Let's visualize potential energy with an analogy. Imagine a spring with balls attached to it, where each ball represents a particle and the spring represents the forces between them. When you stretch the spring, you separate the balls farther apart, which requires energy and increases the potential energy stored in the spring. In a substance, when particles are farther apart, the potential energy is higher. This is because more energy has been put in to overcome the forces of attraction between the particles. For example, gases have particles that are very far apart compared to solids and liquids. Therefore, gases have a higher potential energy. In contrast, in solids where particles are closely packed, the potential energy is lower. Now let's move on to the second component of internal energy, the kinetic energy. Kinetic energy pertains to the movement of particles. In solids, particles are in fixed positions and only vibrate. This means their kinetic energy is quite low. In liquids, particles can move around each other, so their kinetic energy is higher than that of particles in solids. In gases, particles move freely at high speeds, giving gases the highest kinetic energy. The faster the particles move, the higher their kinetic energy. Additionally, the kinetic energy of particles increases with temperature. For instance, when you heat up a gas, its particles move faster, thus increasing their kinetic energy. Let's look at the overall internal energy in different states. Solids have low kinetic energy and low potential energy because the particles are close together and so have the lowest internal energy. Particles in liquids can move around each other and are slightly further apart. Overall, liquids have a higher internal energy than solids, but less than gases. Gas particles move freely and quickly and are far apart, so they have high kinetic and potential energy. This means gases have the highest overall internal energy among the three states of matter. By grasping these concepts, you can see how energy transfer and transformations play fundamental roles in natural processes and technological applications. Each state of matter behaves differently due to the varying internal energies, affecting their physical properties and interactions. Today, we explored the concept of internal energy and its components. Here's a summary of what we covered. We defined internal energy as the total energy within a substance, arising from both the motion and arrangement of its particles. We used the analogy of a spring to understand potential energy, where particles that are farther apart, as in gases, have higher potential energy compared to particles that are closer together, as in solids. We examined how kinetic energy relates to particle movement and temperature. Faster-moving particles, as seen in gases, have higher kinetic energy, which increases with temperature. With this foundation, you now understand how energy is stored and transferred within substances. This understanding is crucial going forward in this course.